This is the PCB scenic view. If this is your first time seeing the original Smith chart, don't you get the feeling that maybe it's something RF engineers used to weed out newbies? It's just packed full of little circles. Looks like a math teacher's revenge. But today, I'm here to tell you it's not magic at all. It's just a map. And it's even simpler than Google Maps. We just need to remember five things first. The center is a perfect match at 50 ohms. To the left, the impedance gets smaller and smaller. To the right, the impedance gets bigger and bigger. The upper half is inductive. The lower half is capacitive. Congrats! By getting this far, you're already 50% better than you were yesterday. So, next up, the thing the Smith chart loves to do most is scare people away. For example, the load is 25 plus J20, 50 ohms. Don't panic, just divide everything by 50 first. That gives us zero point 0.5 plus J 0.5, which is right here on the chart. That's right, all normalization does is divide by the reference impedance. No calculus involved and no demon summoned. Alright, now let's get moving. If you add a series inductor, it moves upward. If you add a series capacitor, it moves downward. And here's some good news. Its resistance stays the same. You're just walking along the same circle. If you ever forget this later, just remember one thing. Inductors go up, capacitors go down. That'll pretty much keep you on track. Parallel components are a bit trickier. They'll say, I want to switch to a different map. So set the impedance chart aside for now. Let's switch to the admittance chart. Then, if you keep adding parallel inductors, the point moves downward. If you add parallel capacitors, it moves upward. Don't ask why, just remember it for now. Once you get used to it, you'll see it actually makes a lot of sense. Why does every single person want to aim to bring that specific point toward the center? Because the closer it is to the center, the much better the overall match will be and the less reflection you will actually get. And the boss gets happier the closer it is to the center, but the further out you go, the higher the VSWR gets and the signal starts bouncing around. Power starts reflecting, and eventually the antenna will have you questioning your life choices. So the center point is our ultimate goal. Let's look at a real world example. The load is 25 minus J 30 ohms. Step 1, plot it on the chart. Step 2, add a series inductor. That'll move the point upward. Step 3, switch to the admittance chart. Add a shunt capacitor to keep adjusting, and finally, with a snap, it lands right back at the endpoint, 50 ohms, perfectly matched. See? It looks like magic, but really, it's just following the map to guide our target toward the center point of 50 ohms. Today, you only need to remember three things. First, the Smith chart. Yeah, it's like a samurai's magic, but it's really just a map. Second, the center point. That is 50 ohm matching. Third, capacitors and inductors will move the impedance point. If you used to close the page whenever you saw a Smith chart, I hope from today on, you'll at least give it a second look, Who knows? Maybe one day you'll even find it pretty interesting. Thanks for watching.